Okay, in this video, we're going to talk about enumeration, random numbers, typecasting, and static methods. Okay, so let's get started. Okay, so in this video, we're going to create our own data types called enumerations. We're going to create a class called coin that will use a random variable. It'll return a random integer. And in the coin class, we will make a method called coin flip that will return one of the coin face names. So it'll return one of these enumerations. And then we'll create a customer class with two attributes, name and the gender. And one of the gender names will be either male or female. And we'll use our coin flip in the customer test application. Right, and then there'll be some other methods here as well, and we'll go through that as the video progresses. But this is the basic diagram or UML diagram of our the project we're going to make right now. Okay, so first let's set up our enumerations, right? Our own data types. So I'm going to create a new file, new item, code file, and we can put our enums in one document. So I'll just call this enums.cs. Go ahead and add that. And then the syntax for enumeration would be public enum and then the name of our enumerations. So we're going to have the coin face one first. So coin face names. And then a set of brackets, and then we're going to create another one for the gender names, right, the male and female one, and then also a set of brackets or curly braces. Right, so for the coin face names, there's two faces on a coin. We have heads, comma, and we have tails, right? And the reason these are capitalized is because these are actually constants, right? They don't change in value. If you don't assign a value to the enum, then by default, head, since it's the first value, would be 0, and tails would be 1. But you can assign your own values to these numbers here. So instead of using 0 and 1, I'm going to use 1 and 2. And then for gender names, I'm going to do the same thing. So male will be 1. Female will be 2. Okay, and then that's going to be it for enums for now. Right, they're already defined. They're in a file within our project, so we can access these enums in any file or any class that's part of the same project. Okay, so now let's set up our coin class. So using system public class, and we'll call it coin, and a set of empty brackets. Okay, so the first thing we want to do is we want to create our random number generator. It's very easy to do in C#. We'll set this to private. It'll probably a private instance variable. The data type would be random. It's a class called random. The name, the identifier for this random variable could be something like rand. And then we'll invoke the random constructor. Okay. The next thing will be we'll need to declare a method so we can the method to flip the coin, right? And it'll return either an integer value, or in this case we want to return one of the actual coin face names. All right, so the coin flip is going to be publicly accessible to the other classes in our project. So we'll set it to public. It's the return type will be coin face names, right? Coin face names, if you remember, is the enum, so it'll return either heads or tails. And then the name of the method, which we'll call coin flip, and it has no arguments, so an empty set of parentheses. Okay, so now the reason there's an error is because we need to return one of the enums. Okay, so let's get one of the values, so we're going to return it back to the user. So let's declare a variable coin face names is the type. The identifier for this variable will be face, and we'll set it equal to, and then to get a random number from the random number generator that we declared here, access that but through the object, right? We created an object called rand, so rand, and then the access member operator, and then we have all these different methods available to us. The one we want is going to be, we want the next random number in our random number generator, right? So we want next, and then next takes has different constructors. Oh, I'm sorry, different different parameters or signatures. So we can just leave it empty. It'll return a non-negative random number. Well, that sounds okay. The second option, int max number as the parameter, returns a non-negative number less than the specified maximum. It'll be one less than the less than the specified maximum. Or we can use option 3. Returns a random number within a specified range. Min value the inclusive lower bound at the random number returned. Right, so the way to do this is we want to return back a value between the range from 1 to 2, right? We either want to return a 1 or a 2. So this would be the minimum bound. So that's 1. And you would think to put 2 here and finish it, but the problem is that it's not inclusive, right? So it would only, this, if you leave it like this, it would only return a range from 1 to 1, right? And we don't want that. We want it from 1 to 2. So we need to set this to 3, right? If we set this to 3, then it will return a number between 1 and 2, right? And then we have another problem here. It says cannot implicitly convert type int to coin face names, right? Because this is a coin face name. This is an this isn't an integer. If I had put this the data type for this variable is int, then the error goes away, right? But we don't want an int. We want a coin face names. So let me change that back. So the way to fix that is to use the casting operator, right? So you put in parentheses whatever data type you want. So I'm going to put coin face names. Okay. And now this rand.next will return an integer from 1 to 2, that integer will be converted to a coin face name, and then that value will be stored in a variable called face. But the problem is, um, since this has a return type, normally we deal with methods that the return type is set to void, so it doesn't return anything. Here we must return the coin face names, so we need a return statement. So here we're going to return the face, right? So we're going to return whatever's in this variable here. Okay, so now we've set up our coin. Let's go ahead and test it out. Let's create a new file here. We will call it customer test. We'll come back and define the customer class in a little while. All right, so we'll do customer test. Okay. So here we'll do using system public class customer test, and then we'll need our main method so we can start testing our application. Public static void main. Okay, so let's test out our coin. All right, so let's create a coin object. So coin, we can call it obj equals new coin. Here we invoke the default constructor. Invoke default constructor. But we didn't define it in this method, right? If you don't define a constructor, then C# will automatically generate one for you that you can use, right? Not always appropriate, but for this case, it's okay, right? So just keep that in mind. Even though we didn't define a constructor, there'll still be one implicitly created for us. Okay. So then now, let's see our coin flipping method. So what I'm going to do is I'm going to print to the screen the coin flip, right? So you flipped placeholder, and then we'll call the object obj access member operator, and here's our method we just defined, coin flip. Now we run this, it should show us either heads or tails, right? So control F5, tails. Let's try it again. Tails, heads. Okay, so it's kind of working. Alright, so there's a few other things we can do with this application here. Since we need to learn a little bit about static methods, right? What does that mean? What is a static method? Right, so a static method or static variable would be one you could create without having to invoke the constructor, without having to create an instance of the coin class, right? So let's say I want to create a static member or static variables and a static method. That way I don't have to create an object of type coin. What you can do is you can set its members to static, right? So let's say this is private, this is static, and then here public coin face names. This method we can also set it to static here. right? So then now we go back here to the customer test. Now we have an error because coin.coinFlip cannot be accessed with an instance reference. Qualify it with a type name instead. All right, so what does that mean? In other words, this is a reference. This is an instance of the coin class, right? So we don't want the instance anymore. We just simply want to use the method without actually having to create a coin object, right? So then now what I can do instead is qualify it using the class name instead. So the class name is coin, then the access member operator, and then now we have coin flip, right? And now I have access to this method. I didn't have to create an instance of it, and it works just the same. Okay, so let me try that out. And it still works. Right, and if you wanted to keep testing your coin class, but you don't want to be control F5ing this all the time, we can encase the statement in a for loop just so we can test it out. So for int index, set it to 0, index while it's less than maybe 100, index plus plus, right? And then now we can get this statement, cut it out, paste it here. Okay, now let's run this let's run the coin flip 100 times and see what happens. Right, so heads, tails, tails, heads. Yeah, it alternates. It works. It's very random. Okay. Okay, so the next thing we need to do is we need to define our customer class. So let's go ahead and add a new file. Code file. Customer. Okay. Using system public class customer. Our customer will have two attributes: private string, a name, and then private, and then here we want to store the gender. So we want to store it as a gender names, right? The other enum that we had defined earlier. Here we want to store one of these for the gender, and we can call this instance variable, we can call it gender. Okay. We'll need some methods. I'm sorry, some properties. Public string capital N name. Return the name. Set name equals whatever value we assign to the property. Next, we need a property for gender. Right, so it's going to be public gender names, and then capital GENDER. Right, and then the same thing, get, return the gender, set gender to the value. Okay, so now we have our properties. let's define a constructor for our customer class, a default one. So that's public customer, no no parameters. And when we first instantiate this class, we want to set the name to some default value. So I guess we'll call him John Doe. And we want to assume, we want to make John Doe, we want to make him a male, right? As just as default. So to access the enum, you type the name of the enum, enames, dot, and then you see now we have the choice of female or male. So we're going to choose male. Okay. And then we can create a simple method to display the customer information. So public void display info. Oops. And then we'll do console.write line, and then we'll display the name, call the name property, and then console.write line, display the gender. And then call the gender property. Alright, so let's test this out, see how this works. Let's go to customer class. We don't need this right now. Okay, so let's create a customer. So customer obj equals the new operator, and then call the customer constructor. Right? And then now we can do obj dot display info. Okay. Now let's run it, see what happens. See, so it's John Doe. We haven't set any values yet, but we will soon. Right? But if you don't set any, then it'll just display the default ones. Okay, so then maybe what we can do now, we display the info first. Then let's go ahead and set the values of obj. We'll set the name and the gender. So then obj dot first of all name. We'll do Mary Jones, and then we can do obj dot gender equals gender names dot female. Okay, so let's try that. Oh, last thing would be to redisplay the information. Right. So first we display the default values, then we change the name and the gender, and then we redisplay the information again. Right. So first we had John Doe male, then we had Mary Jones female. Okay, so now let's make this program interesting. Right. So instead of assigning the either male or female, let's flip a coin instead to decide if Mary Jones is male or female. All right, so to flip a coin, call your coin class coin dot coin flip. Okay, so we have an error. What is that error? It says cannot implicitly convert type coin face names to gender names. An explicit conversion exists. Are you missing a cast? Right? So again, we need to cast. Right? So this method returns a coin face names. Right? It returns one of these, but we need to typecast it so that way we can convert it to one of these instead. Right? So again, use the cast operator. So then that would be gender names. Right, so here we get a coin face names, convert it to gender names, and then store it in the gender property. Or assign it to the gender property, excuse me. Okay, so then let's see what happens. Control F5. Right, so randomly we assigned Mary Jones the gender male. Let's try it again. Okay, now she's female. Try again. She's male. Female. Female. Female again. Let's see if we can get one more male. Nope. Nope. Okay, male. All right, so now the coin flip is determining her gender. Okay, so the last thing I wanted to show you was how you can use an enum in a switch statement. All right, so let's say we want to write a method, and that method based on the gender will assign either Mr. John Doe, or if it's female, Mrs. John Doe. Right, so we can make that kind of decision using a switch. Right, so and we'll call that the prefix. Right, so then public void public string. We're going to return a string. Set prefix. Right, so we're going to return a prefix based on the gender. Right, so then we can create a variable here called string prefix. We'll initialize it to nothing, or we could just write null, and then we can return the prefix. Alright, so somewhere in between here we have to make a decision in between here before we return this. Alright, so what you can do is you can use a switch and the enum. Right, so we type the switch out, switch, and based on the gender. So where is the gender stored in this class? Right, so that's the value we're going to use to determine if it's Mr. or Mrs. Right, so gender stored here. So then gender goes there. So that would be the case expression, gender. So then case 1, or instead of case 1, we do case gender names dot male colon and then break. And before the break, we'll set the prefix. So prefix equals Mr. Right, so for the case where the gender is male, the prefix will be Mr. Okay, so then case where gender names dot female we set the prefix to Mrs. and then break. Okay, and then the last thing we need in a switch is going to be the default case. Default case, we can say prefix remains null, and then break. And then we won't actually need it here anymore. There you go. So one of these will work, right? If neither male or female is assigned, then we just won't say anything at all. And then we'll return the prefix, right? So, but where are we going to return the prefix to? Well, here under display info, we want it next to the name. So that way it would look something like this, Mr. John Jones or whatever, right? So what we can do is add another placeholder. So then the Mr. and Mrs. comes at the before the name. So then we'll place, we'll call set prefix here. Right, so set prefix, whatever the result, whatever it returns, will return to the first placeholder, and then the name will return here. Okay, so then now let's try this out. Right, so Mr. John Doe, he's male, and then randomly Mary Jones was assigned female, so it says Mrs. Mary Jones. Let's try it again. Mrs. Mary Jones. Mr. Mary Jones, because she was randomly assigned the male gender. And that's pretty much it for enumeration, static methods, typecasting, and random variables, random numbers.